Hello everybody, welcome to the live stream where we build the Xenon Thrust Vector Control rocket. Sorry if we had some minor delays, but now we should be good to go. And you might see right here is the Xenon booster, main booster part that houses the entire TVC system and all of that. So if you look over here, this is the TVC system, right here. This is the 2-axis version, and it can rotate the motor in all directions like this, pretty well. And so we're gonna put it in this rocket today and just kind of assemble the entire vehicle. So let me just move the rocket cradle. So just get to putting this in. So this is the bottom of it right here, where the actual TVC mount goes. And I'm gonna pull out the cables so we can actually test it once we put it in. So I'm gonna try to just slide it in how it looks, and then I'll actually center it so it fits good. So just slide it in first. Okay, found the hole. And then let me grab one of the M3.5mm screws and screw this in. Yeah, I'm really sorry if there's any delays in the stream. I couldn't help that. It's probably most likely Wi-Fi problems. I need a mechanical drill for this. I have this really efficient screwdriver though, that screws it in both ways each turn, so it gets it done faster. Okay, there we go, one screw. And there's the next one. Let's get that screw in. Oh wait, there's the screw. Just gonna screw this one in now, and then we should be good to test out the TVC system. I was planning on building the entire TVC system on the live stream, but that would take too long. So I just decided that I would do it like this. Okay, we almost got the screw in. Okay, let's test out. Wait. Okay, you can see we have a pretty good actuation right here. I say we test out this first, real quick, before we start putting on the upper part. And I just painted this all yesterday and the day before, so that's why it's painted now. And if you follow me on Twitter, you'll know that it was blue before. So, wait just a sec. How am I gonna do this? Wait, let me go grab a battery. Oh wait, real quick. Okay, this is the new flight computer for the rocket. It's the Omega flight computer. And it's gonna be flying about right here in the rocket. And we got an LED, some pyro channels, and it can do TVC, data logging, acceleration data, pretty much everything in a standard flight computer. So let me go get a battery real quick. here's the battery. Yeah, the code I'm gonna show you, or the code I'm gonna show you for this. Oops. The code I'm gonna show you for this is just a test sequence. It's not anything fancy. I do have the 2-axis code written though, for the for the actual flight. I have some PID control stuff I wrote like a month ago, so that is going to be flying on the Mega Flying Computer. I just need to receive the rest of the parts, like the micro SD card holder, stuff like that. Okay. So I say we connect this up now. Wait, first we should try to power it on. Make sure this thing turns on with this 9-volt battery. Wait just a second. Ooh. That's a really shaky connection. This is why I use terminal blocks now. So it's probably gonna turn off while I'm putting these in, but I can just power it back on. I hope this works. I haven't even tested it in the tube yet. I've tested it out of the airframe. Let me get some wires to put this in. Makes it a lot easier. Oof. It's hard to get in. Wait, let me see this. So here's one. So I'll put this one in here. I hope this is entertaining. Oof. Oh yeah, I kind of remember this problem. Wait, there's a problem where an Arduino doesn't work with a 9-volt battery connected to the battery input and ground, so it doesn't control anything like servos. Oh, this is so frustrating because I only have 2 USB ports on my computer, so I can't plug this thing in. You can see there's a full actuation on that. I guess I can unplug the mic if you guys are okay with me unplugging the mic. I can unplug the mic for a minute, show you this, and then I can plug it back in. Just say in the chat if you want me to show you it actuate real quick, and then wait, that's not calling. That's bad. We're not getting any from that reset. So yeah, just say in the chat. Hi Yukon, welcome back to the stream. So I could plug this, the rocket, or the Arduino Mega into a USB. But I'll have to unplug the mic to do that. I think I can do it real quick, hopefully. Oh, I'm so nervous about this in case it doesn't come back on. Yukon, if you just joined, there's only 2 USBs on my computer, so I have to unplug the microphone in order to get it to actuate. And it's not completely centered. It's centered on the y-axis, but it's not completely centered on the x. So I guess if you guys are saying actuate it, here goes the mic. 3, 2, 1. Okay. So I don't know if you guys said that, if you can hear me or not. I don't know if you can hear me or not, but hopefully you can right now. And you just saw it actuate because, wow, that was kind of stressful. Okay. And did you see the actuation? That was some test code I wrote like 2 days ago. It just actuates like up, like I'm pretty sure it's up 5 degrees and it goes up 5, back, and it goes on all axes, and then it goes diagonal on flipping on 2 axes. So we got that. Now it's time to build the rest of the rocket. So we just got the TVC to actuate. Now, so I need to unplug the servo pins. Wow, that's hard impact. These things are really hard to undo. I should probably maybe sand the inside or sand the outside of them. These things are serious. It's like they're made. What's this? There we go. Okay, so. Oh, that was 2 extensions. That's why it's weird. Okay, we got the rocket disconnected, as you can see. And then these are just some extensions for the thing. So yeah, I have the Mega Flag Maker right here, which is undergoing the soldering, and then I actually have 5 of them, because you have to buy them in bulk from the PCB manufacturer, so I have 3 more. And then I have this one that I'm doing test fitting with right here. Okay, now for the second part. So I have this, I 3D printed this coupler because I didn't feel like buying one from Apogee Components. So I 3D printed this full coupler right here, which is going to go inside the rocket. It's able to use screws to screw it in if you don't want the rocket coming loose at all. But for this, and because I don't have any more screws, I'm just gonna just push it in. So I don't know if you can see this real good. Wait, let me just adjust the camera. Let's see that. Is that a little better? That's a little bit better. Let's get the rocket a little closer. And then we got this right here, which is the upper part, which houses the parachute ejection system and the nose cone. And then here's the actual 3D printed nose cone. And it's not that aerodynamic because this rocket's never gonna fly, and it's just a test bed for TVC. So we need to put together the parachute ejection system first, real quick. Hi Texas. So here's the parachute ejection system. It's a 3D printed part I made, and the problem is it uses a U-bolt instead of an I-bolt, and I don't have the other nuts for the other side, so it goes in, but there's nothing to hold it in the other side, as you can see. So I need to get those before I can actually put that together, or put that on. And then it holds a pyro right here, which I have somewhere. And then we got, these are actually using different screws. These are probably, these are using Allen wrenches. Maybe we could oxidize maybe or something like that. Parachute ejection system. And I just got this off the print bed actually. So what I need to do is remove some of the support material on it first. So I'm going to switch from this. Let me know if this is interesting, because to a lot of people this is not that interesting. But to me it is. Okay, we got one out. Let's do the other. Okay, I'm just going to take this booster part off, even though there's only one motor. Hopefully, I'm making, there's a secret that I'll tell you if, everyone wants to know the secret. And the secret will be coming in 6 months. That's when it will be finished, hopefully. Sorry, you can't see this on camera. Just sliding the parachute ejection system up in the rocket. It's kind of hard for me to film this because I need a lot of light, and in the camera, you don't like light. Where's that hole? Okay. Just give me a sec. So it's so hard to turn this. Come on, just find the hole. Oof, that hole is far off still. See what it is now. Sorry if you guys can't see anything. Okay. It's starting to look aligned. Feel free to ask any questions about the rocketry or the Delta program or anything like that sort of nature. Oh no. Lost a screw. There we go. We found it. Okay, I'm real quick. I need to switch bits again to an Allen. Here. So here's it. Maybe this is the correct bit. Yep, that's good. Francis, you need to explain more. I don't really understand. What do you mean by how is your code? Where is this thing? This thing actually screwing into it right now. Let me feel. Oh, I think it actually is screwing into it right now. Wait, wow, I got really lucky on that. Or not. Like. Hopefully you guys don't mind this too much. I'm gonna have to change the... I should have planned this out a little better. But I can't do it now that I'm in a stream. I think it might be slightly over. Oh, I actually found the hole. You're asking how my code is for TVC? It's good. It's not using the preferred guidance control laws that I would like to use, like quaternions. That's maybe in the future for the surprise thing. It's almost flight ready. I would say the code itself is ready, but I need to do tuning for like PID gains. So that I'll have to adjust in the code. But yeah, other than that, I would say it's pretty flight ready. But yeah, it can run into gimbal lock because it's using something called Euler angles instead of the preferred quaternions. Oh, I think it's finally going in. Okay. Got one in. Looks pretty good. Let's check for the second one. The second one is right here. No, wait, just a sec. Oh my gosh. This is just so annoying right now. The thing is so close. I must have drilled the hole slightly off. the Omega flight computer. Which one? This one is just I'm using for test fitting and for cool pictures, I guess. Yeah, this is just that. And then I have 3 of them right here. These are ones that I just haven't done really anything to. And then I have this one, which is actually what I'm soldering on. As you can see, I've soldered on the TVC. The terminal box right here is Pyro Channel 1, Pyro Channel 2. These are for input for battery to give power to the entire flight computer. This is for input, and this one is for a switch. Then we got 2 MOSFETs controlling each pyro. The TVC header pins right here, and then an RGB LED. So what I still need is this is the gyroscope and accelerometer, micro SD card, flash chip, pressure sensor, the voltage regulator, and then I need a ton of other capacitors and resistors. F in the chat for tight tolerances. I guess this can live. Oh, it's actually really strong with wind screw. Might be even able to. I'm not sure about fly, but that's pretty strong. This nose cone needs a major redesign. This thing takes so long to print the nose cone. I was printing this at, I think, 90 millimeters a second. There's like 10% infill on it, so it's really lightweight. And this thing took, I think, 14 hours to print. That's just insane. Yeah, this is all Bluetooth. The bad thing is, when I'm cutting it and drawing holes into it, it's not as easy like a thin-walled cardboard from like Apogee or something like that. So yeah, that's the bad thing about it. It's super hard to cut. Yeah, sorry, wait, let me fix the lighting a little bit. Is that a little bit better? And yeah, it is Bluetooth. The outside of it is white because I painted it, but the inside, yeah, it's still blue. So let's see how this thing looks. And then we put the cover on the tube right here. Slide that on. And here it is. This is how tall it is. It's about, I would say, probably 4 and 2 inches. I don't know. I'm not that good at Imperial. Metric is better than Imperial. Everyone. That is a true fact. And yeah, the flight computer is going to go right here in the rocket. So yeah, that's that. I pretty much got a lot of things done in the stream. I guess I could keep it going for maybe 20 more minutes if you guys have any questions. But other than that, there's not really anything else to do. For the stream. This is like the shortest stream I've ever done. Or no, I did a stream that was shorter. But yeah. This TVC is pretty nice. I would say it actually, it's pretty well. Oh yeah, the nose cone needs a major redesign because I designed this before I got the Bluetooth, and I thought it was a standard 74 millimeter tube, like the thin walled and stuff like that, on the standard 74 on the OD, or on the ID, and it turns out it's actually 76, so it's 2 millimeters off, or even more. So I wrapped it with blue tape, but still, that's only 1 millimeter. So I have to fix that for the next version. But yeah, that will work. This rocket's pretty big, I would say. There's a lot of TVC stuff that I want to fix. Like there's a little bit of wiggling, so I can fix that in the next revision of it. I'm so mad when I was painting the black part right here on the Bluetooth. the airframe. I accidentally sprayed a tiny bit onto the white, so I went over it, but I didn't get all of it. So you might be able to see. Wait, there's a faint line right here. I don't think you can see because of the lighting, but it kind of looks like a SpaceX Falcon 9 interstage, because like when it comes back to land, it kind of has like a tint to it. Yeah, I guess I'll just put this on the rocket rails. But yeah, I'm really excited about the mode of flight computer. It's gonna be great, and I'm open sourcing the TVC system in probably a month, maybe after 2 more revisions, maybe 1 more revision. So I'm open sourcing that, so that's gonna be great. And I guess I would just reveal the new thing, which you won't know unless you watch the stream. So there you go, you can watch the stream now. And the thing is, the new thing that is coming is the Delta, no, never mind. The Delta TVC Pro. It's like a professional version of it, and it's gonna be much, much, much better than this one. It's gonna be, this one is rated for F, maybe G motors, and the Pro is gonna be rated for all high power, like E, or no, not E, H and J and stuff like that. So yeah, it's gonna be much better than this version, what I've heard right now. It's also gonna use better servos. It's gonna use MG90 instead of SG90, so higher torque, better performance, more accurate, all of those. And it's also gonna be a lot stronger, and it's gonna be made out of PETG instead of PLA, so a lot more stronger, more heat resistant, stuff like that. And yeah, it's gonna be for 98mm rocket, so it's gonna be slightly bigger. Wait, just a second, I can show you. You don't understand how big that is. It's pretty. So this rocket is 80mm right here. 80. The new one's gonna be that big. It's quite a bit bigger. And we're also gonna have a new version of Omega for that. It's gonna be the Omega V2. So it's gonna have 4 pyro channels. It's gonna be a better processor, better designed PCB. And yeah, and the the TVC Pro version is coming out in like 6 months. And that one, I don't know if I'll open source. I might have that available to buy on my website, which if you don't know is deltaspacesystems.wixsite.com/rockets. So go check that website out, and you'll learn about all of these rockets and stuff like that. And I just did a small update to it the other day, so it's a little bit better and nicer. Yeah. So, if you have any questions, make sure to ask them, because there's nothing else to really do. And if you have any other questions that are more personal about the program, you can reach out at deltaspacesystems@gmail.com, or my personal email, colepertzer@gmail.com, on those. And I'll be sure to answer. Yeah, the new TVC is going to be dangerous for the first couple tests. That's why I'm going to build a new rig for it. But this thing's going to be made for like really high powered things. This one I want to get, I'm planning to make this rocket go to 10,000 feet. And if we get someone to ask a question any question, just because I feel like it, I'll tell you the new rocket name. And it's not Xenon. This is the Xenon. It runs with the normal Delta TVC and the Omega flight computer. And then we have Horizon, which is the non-TVC rocket. And there's going to be a new rocket in 6 months. Or if you don't like the name, the chat can decide on it. But I think the name's pretty cool. So if you want to know what the name is, just send a message in the chat and I'll tell you what the name is. I guess you could do a small cluster motor, though it would just have to be like a really weird design, because there would have to be like bumps if you wanted to make it so there's not pressure buildup, and make it reliable and like not as much weight as a normal big motor. And like if I were to do that, I'd probably do like 4G motors or 4H motors for 1J motor. And they're so close to the size that you really can't make that specific impulse. Yeah, and plus, clustering is hard to ignite, because if you don't ignite one, then the TVC has to work extra hard to correct for that loss and thrust on that one side. So I'll tell you the new rocket, then I have to end it. The new rocket name is Velocity. Yeah, it's Velocity. I think it's a pretty good name. And yeah, there's gonna be details coming up about because like right now, all that's on the website is Horizon. There's gonna be details on Xenon and Velocity coming out in the next month, so stay tuned for that. Is the live stream on? I just wanted to check and it says live stream offline. Oh wait, it's coming. See? I think it's on still. Yeah, it's still good. The TVC won't break because it's gonna be, it probably would break, though it's still really strong in this configuration. The motor tube will definitely handle it. I know that. The inner gimbal and outer gimbal, I'll have to probably get much stronger screws to do that. But the main thing is it's going to be made out of PETG, which is a much stronger plastic, and it's much more heat resistant, so you don't have like if you ever watched the bps.space Falcon Heavy launch, the motor tube melts, so that's why we're going to make it out of PETG, so we never have that happen with the Velocity rocket. But though it is harder to print and it takes more time. But yeah. Okay. I think I have to end it. Any last questions? And then I'll have to end it here. And if you're wondering, why not just fins? First of all, I think I went over this a long time ago on my Twitter. Oh, that was about RCS though, when I was about to do RCS. The thing is, first of all, fins for rockets that are coming up to big scale, like how the Velocity is going to be, it's going to be about 10 feet tall. Maybe 8 feet tall at the lowest. but it's going to be seriously super tall. So you would have to have such a big fins on it, and they would have to be very light too. So they have to be carbon fiber, fiberglass, something in that nature like that. And that brings up the cost drastically. Carbon fiber fins are super expensive, and such big fins, you would have to have a fin, like a metal fin. I forgot the name for it. You have to have a metal fin thing and to hold them. So yeah, you could just fins that have servos. You could, though. The code is so much harder for fin design than TVC, and TVC has already proven to work. Like, rockets use them, and for the scale we're going to, we're just going to use TVC. Okay, I think I have to end it here. And if you want any more updates, follow me on Twitter. This is the time to plug all of the social media. Twitter, Instagram, my website, deltaspacesystems.worksite.com, and of course, here on YouTube. So, goodbye everyone. I'll see you in the next one, and bye.